Mm, yeah,
Sure.
I use a technology of Python to discover all the connector adapter and do not need to append all the all the uh, connector adapter to the adapters. Yeah,
Oh,
this make
this is
it easy.
interesting. This is interesting.
Yeah, another point is move all the connector adapter to a single individual files. Yeah, this is why I did this is reduce conflict. Yeah, and another main point is make it lazy import. Since we we should use only one connector in our production environment. Yeah, so we do not need to install all the uh, dependencies of all the remote connector. Yeah.
Makes sense. Makes sense.
Okay. Good. So I will finish this PR. Yeah.
Nice.
Okay.
Another 843. I have a brief update. I have updated the changes merged to the VM yesterday. Yeah.
Cool, cool, cool. So I think th this PR could be merged soon. I think this is very, very useful. So I was testing Jai's new updates today, and I just realized that the updates on the VM side hasn't been merged because there is a CI failure. But I think with this, it could be much more easier because we can just bypass the the reviewer review processing VM.
Yeah.
Yeah,
And
on that side, I just rerun the failed test, but I'm not sure that's related or not. It should be not related to this PR, but
It should be not really.
yeah,
I think VM CI is not just not stable enough.
after this PR merge, and we can use LMCache in the VM by this way. Yeah. So we should never update the LM connector in the VM, so we can maintain it in our repository. The last one is 764. This is uh, uh, a PR with several weeks. Yeah, I'd like to ask for the review. Yeah.
Okay, I will take a look when if I got a chance. So yeah.
Yes, thanks. Yeah. And the next one is a question. Yeah, I think this is a common question. In our company, we use VM, which is built last month from the main branch. And in that time, the VM is dependent. The torch version is 2.6. And now I notice LMCache is dependent to the 2.7. So it make our production conflict. So I'd like to ask this question. Yeah.
Yeah, I think one way is to change the PyTorch version in the
Mm-hmm.
PyProject.toml. I think this should work. I think there is no hard dependency, but it's just like because VLM previous
Oh,
the
yeah.
latest version is using the 2.7.0 version, Torch version. So we want to be compatible with that. But I think if you want to use the older version, it's okay to directly modify the PyTorch version in the PyProject.toml and build it again. And I think
Mm-hmm.
there's another way to, so let's say if in your current environment there is already a PyTorch installed, let's say PyTorch 2.6.0, I think there is another way to just directly use the the torch. Let me do a quick search.
It should be something like build without isolation or something.
Yeah, no build isolation. Yeah. So I was about to say this. Yeah, thanks, content. Oh, so this one is also so basically when your environment
Mhm.
already has a PyTorch, it will not force PIP to spawn a new, you know, a temporary virtual environment to compile the LMCache again, but just use the current environment to do the compilation. But that also probably requires you also to modify the PyProject.toml.
Okay. Okay. So I will search the flag and look how to solve my question. Thanks. Yeah.
Yeah. So just feel free to reach out to us.
Okay. Thanks. Is
Okay.
that oh?
Okay, great. Thanks, Paulo, for the update. Okay, any other questions? Okay, then Kuntai.
Yeah. So on my side, first, like there will be an incoming PR about hybrid memory allocator for sliding window VLM, and that PR affects Ion cache in every aspect because it changes the KB cache layout. So we need to be aware of that and make corresponding changes for sliding window models and also potentially incoming OpenAI models. And the second thing is I'm investigating two possibilities. One is using Ion Cache for preview-only optimizations. I'm drafting a design doc and looking for reviews in on the Ion side. And if the real path, and it will very likely we need Ion Cache to offload all the KB caches into CPU during the implementation. Yeah, and also I'm recently investigating the potential of KV cache compaction. This is more machine learning side optimization, and once I got some initial results, I will push it into like we'll push initial support into LMCache and let people use it and get the feedback. Yeah.
Sounds good. Okay.
Yeah.
Yeah,
You can please move on.
yeah, Yihua, you can continue to your next item.
Okay, yeah, I'm writing something down, but this topic is actually keeping my mind for a very long time. So let me try to finish writing it. But basically, what we want is I'm just trying to propose something that is we want to is there is a potential solution that we separate the M cache to another process for KV cache offloading and KV cache transfer. Uh, so this might have a few different different benefits. The first thing is first of all, it currently Amcache it's it's in the same process as the VRAM worker process, and every time VRAM do an inference, it will use the CPU cycles to launch the CUDA kernels of Amcache, and as a result, it will unavoidably have inevitably have some performance impact of VRAM's inference. So if we can separate the AM cache to another process, it will do some it will have a minimal impact to VRAM's worker processes. And also another benefits is we by doing this we can enable the direct share of KV cache across different VRM on the same node without having this AM cache server. So let's say we have 8 GPUs on a single node, and these 8 GPUs are running eight different VRM instances serving, let's say, a Llama 8B model. Yeah. And right now, if we are running AM cache and we want to share KV cache across these 8 instances, what we need to do is basically we have to launch another process called AM cache server, and every VM instance will like copy and transfer the KV cache between the VM worker process and the AM cache server. But if we can separate the LMCache, we can only have a single LMCache process that does all the H2D and D2H copies. So basically, there is no like inter-process communication, like or KV cache transfer across TCP, but it's just to have a centralized memory pool, and all the communication is just D2H and HDD memory copies. And the third benefit is we can reduce the communication overheads across TP workers. So this could be the case where under the prefill decode desegregation use cases, we still need to do some communication to make sure that all the TP workers have the corresponding KV caches. But if we can if we can have only one LMCache process separated from VRM processes, all the VRM TP workers can share the same LMCache process, and that LMCache process can have the global visibility of everything on all the TP workers. So that's another benefit. And finally, there's a benefit to reduce the time to bootstrap, because right now, if we want to launch a VRM instance with a LMCache with let's say 100 GB of CPU memory pool, it may take more than 1 minute for LMCache to allocate the CPU memory. But if we can separate the LMCache to another process, basically pre-allocate all the CPU memory, we can just do a effortless VRM auto scale. So basically, every time you you launch a new VRM instance, you just need to connect to the LMCache process instead of reallocate a new set of memory. So I saw Kuntai is writing down a question: how do we interact with CUDA graph in this design? I think we are still going through the connect API, but the difference is that the connect API will just do some very lightweight communication, inter-process communication, to tell LMCache, well, this CUDA memory address, this KV cache is available at the address of what, and then LMCache will do this D2H and HDD copy in a separate process. So I think probably most of things can be done in the VRM scheduler side. That's probably doable. And in the worst case, if the connector API is, I think if connector API is good enough to be compatible with the CUDA graph, I think this can also be compatible with CUDA graph. Should scheduler connect locate the same process as VRM? I think it's the same way as the current VRM V1's PD. So basically, VRM scheduler has a connector doing some high level stuff, and VRM worker is on the worker side, connector is dealing the KV cache transfer. But I think maybe in the future, the worker side only needs to do some initialization, basically pass the pointers to the LMCache process, and the LMCache can use those pointers to CUDA IPC pointers to reconstruct all the views of the VRM's page table. And then we only need to do the communication between LMCache scheduler, VRM scheduler process and the LMCache process. That could be probably doable.
Yuhua. So, like, I guess the question I'm asking is that in the scheduler scheduling function, do we repeatedly call RPCs?
Oh, okay. This is a good point. But I think let's maybe take this offline. I just want to
Mhm.
raise a very brief discussion here, and I'm also like looking forward to the feedback from the community, and maybe a better way is we can create a RFC issue on Mcache, and the whole community can discuss the potential like benefits and mean, potential benefits and use cases.
Well, okay. Yeah, since we are running out of time, maybe we can go to the next item and let's have more offline discussion on the what Yuhua just mentioned. Yeah. So Yuwei. Yeah, we can't hear you.
Yeah.
Hey, yeah.
Yeah, so you were unmuted, but yeah, we
Oh,
can't hear you.
yeah, Yuwei is muted, I guess. Or
Yeah, he muted again. He was
okay.
unmuted. Yeah.
So can you hear me now?
Yeah, I can hear.
Yeah, we can hear you now.
Okay, so we are going to connect the MCache and SGLang. So the PR is ongoing. We are in the progress of benchmark. It is the connection with end-to-end retrieve and store instead of layer-wise. Yeah.
Okay, sounds good. Yeah, I think any other questions from the community? Okay, if not, then we can call it for today. And thanks
Oh,
everyone for coming. So,
oh,
are you?
by the way, just wanna mention that I like VLM is supporting P2P nickel style communication. And the major benefit is that the connection does not require configuration. So basically, if we want two P worker or two D worker connect, we don't need to explicitly write the configuration inside inside LMCache connector startup. We just need the proxy server to handle all the connections. And that seems to be a major benefit for auto scaling. So I'm mentioning here, and we can potentially discuss this. Yeah.
Cool. Okay. Okay, sounds good. So I think this is the end for this week's community meeting. So next week it will be 9 a.m. PT on next Tuesday. Yeah. Hope to see you guys next week. Okay, thank you.
See you.
See you.
See
See you.